Now let us look at the assignment number 2. In assignment number 2, we have to write down a program for 8051 in which we have to send the temperature ranges from -4 to +4. So we want to send the data from -4 to +4. Remember one thing, over here we want to send a data which has the positive values and the negative values, and those are well within the 255 limit. So in this case we can go with the signed char. Application purpose, you can imagine the system in which we have connected the output of an 8051 microcontroller to the digital to analog converter. So when you send a continuously values from -4 to +4, what is expected is that you will get a triangle. Now let us look at the program. In the program is written for 8051, so that is why we have to include the file #include regx51.h. After that we have a main function. The thing that we have to focus on is called as a char, and after that we have put down the variable name, that is my data. So here instead of writing a signed char, even we can write down a char. So compiler, it will treat this as a signed char, so there is no need to write down a signed char, it should be a char as well. After that you can say that there is a variable name called as my data. After that there are square brackets is equal to, and what is the value that we want to pass this array. Now what is meant by array? So array is a collection of similar elements. So when we want to pass more than one value, we use an array. Like here we want to pass -4, -3, -2 up to 4. So we have used an array. Now to pass these values to port 1, what we require is one counter which will pass these 8 values one by one to the port 1. So here I have used a second variable called as unsigned char z. Now here z is an index, you can say that. So whenever the index is 0, it will belong to -4. Whenever the index is 1, it belongs to -3, and whenever the index is 2, it belongs to -3, and so on and so forth. So it becomes an 8 element array. After the variable declaration, we have used while one. So while one is nothing but a super loop. After that we have written a for loop in which we initialize the z variable is equal to 0. We check whether the z is less than or 8 or not, and z plus plus. It means that the index will go on increasing. So in the first loop, what happens is that z becomes a 0, pass on the value of -4. Then z becomes 1, it pass on the value of -3. Then z becomes 2, it will pass on the value of -2. And at the last, when the index is 8, it will pass on the value of 4. So once the for loop is completed, once again it has while one, so it will start again from 0 to up to 8 elements. So it will send it again and again. Let us simulate this program on a kill compiler and check out what kind of output we are getting. uVision tool, and from this tool I will be clicking on source group 1. We have to make a right click, and then we have to add existing files to the source group 1, and we are looking for assignment number 2. Add it and close it. So when you double click on it, the program, you can see the program. Here you can see the header file. So as I told you, we want to send numbers, those are ranging from -4 to the +4. Let us compile this program so that ensure that we should not have any errors. So it says that it has 0 errors and 0 warnings at the bottom. Now let us simulate this program. Go to debug window, start stop debug session, evaluation mode, okay. And after that, what we have to do is, what we are interested in, port 1. So go to peripherals, IO ports, and from that you fetch port number 1. So over here we are going to look at the results. So I will run this program stepwise, and let us see what happens over here. So let us run this program. Okay, so this is my first data, that is -4. As you know that in the binary number system we cannot represent a minus sign, so the negative numbers are represented in a 2's complement format. So here FC belongs to the -4. Let us run one again. So this is FD means -3, then -2, and this is what is -1, and then what we have is a 1. And you can go ahead, this is 2, 3, 4, and once again it will jump on to the -4. So this loop will continue forever, okay, as it is in the while loop. So once again over here you can see that the assembled code for the C program. Now let us look at the assignment number 3. So in assignment number 3, what we have to do is we have to write down a program for 8051 in which we have to toggle port 1 50,000 times. Now here we have to remember one thing. This loop is not going to be a super loop or the forever loop. We have to execute this program 50,000 times and then we have to stop. Okay, and one more thing over here is that we have some kind of a counter which will go on counting up to 50,000 and then we have to stop. Now here you can imagine that if I want to count up to 50,000, I should go with unsigned integer data type, which will count the number of loops, and after 50,000 it will stop the program. You can imagine the system as shown in the diagram, where I have connected all the LEDs to the port 1. What is meant by toggling? Toggling means one LED is on, after that the second LED is off, after that the third LED will be on. So alternate LEDs are on and off. So let us write down a program for it, and now let us go to the program. So here, the first of all we have to include regx file, then void main void function is there, and as I am talking about unsigned int z. So this is a counter which ranges from value number 0 to 50,000, and with each loop it will go on incrementing. Okay, so the thing is I was talking about toggling of the port, that is P1 is equal to 0x55. What is meant by 55? It is 0101, alternate LEDs are on and off, and after that the pattern is 0xAA, which is nothing but a 0101. So here you can see that in a previous cycle the LED was 0, in the next cycle it will become 1, in a previous cycle it was 1, and in the next cycle it will become a 0. So this is called as a toggling of LED, and we have to do this for 50,000 times. So here in this program you won't be able to find out a super loop, because after 50,000 we have to stop the loop. Now let us try to simulate this program in a kill compiler. Let us go to the kill compiler, click on write existing files, assignment number 3, add and close. So when you double click on this, you will be able to see the program. So let us try and simulate this program, but before that, whenever you load the program, first of all you need to build the program. So when you build the program, the compiler will convert this your C code into an assembly language code, and then only you will be able to simulate this code. So here I can find out 0 error and 0 warning at the bottom. So I'll go to debug, start stop debug session, evaluation mode, okay, and here I can find out the compile code as well as the port 1. So if you don't find a port 1, what you have to do is go to peripherals, IO ports, and from that you can choose the port. Now let us run this program step by step. So I'll click on this. So here you can see that 55-bit pattern. So alternate LEDs are on. So tick mark means logic 1, and we don't have a tick mark means a logic 0. So I'll click on again. So here you can see that the bit pattern is 1 1. So if I run this, you can see that the bits are toggling, and these will be toggle up to 55,000 and then they will stop. So at the bottom you can see the counter is incrementing, and when it becomes a 50,000 the program will automatically stop. So this is how you can toggle any port. So I will stop this session. Now let us go to the assignment number 4. In assignment number 4, what we have to do is we have to look at the status of port number 1.0. So here we are talking about port number 1 and the line number 0. Then we have to save that status and we have to send it to port number 2.7. 2.7 means port number 2, line number 7. So you can imagine a system in which we have connected a switch to port number 1, line number 0, and we have to connected LED at port number 2, line number 7. So we have to read the status of the switch, we have to store that, and then we have to send it to the LED. So whenever the switch is on, LED will be on, and whenever the switch is off, LED will be off. Let us write down a program for assignment number 4. Now this is the program for assignment number 4. So in this case, we are dealing with the single bit information data. So we have to use a SB data type, and SB data type are declared before void main void. So whether it is SBit data type or a bit data type, those are always mentioned before void main void. Whereas signed char, unsigned char, signed int, unsigned ints are mentioned after the void main void. But in the case of single bit variables, those has to declare before the void main void. So after hash include regx51, you can see that it starts with sbit, and after that name of that variable, that is in bit, is equal to p1 cap 0. So here we have, instead of a dot, we have to use a cap, so that compiler recognize that now we have to read port number 1 line number 0. After that, this is the input line. Let us declare the output line, that is s bit out bit is equal to p 2 cap 7. So here out bit will be having the port number 2 line number 7, and we want to store this bit within our bit addressable area. To declare that, we have to use a bit, and after that we have to mention the name, that is mem bit. So this is how we can store the single bit information. All these single bit variables are mentioned before the void main void. After a void main void, what we have to do is n bit is equal to 1. What is n bit? N bit is port number 1 line number 0. And why we are making it as 1? Because by default, as you know that in a 8051 all the ports are output port, and if you want to convert that output port as an input port or the single line as an input line, we have to send 1 to that line. So when I say n bit is equal to 1, I am going to make port 1 line number 0 as an input line. So we want to read the switch at that particular line. After that, we have a super loop while 1, and what we are trying to do is memory bit is equal to n bit, means that port 1 line number 0 will be read, and it will be, the value will be assigned to the memory bit. After assigning to the memory bit, once again I am reading this memory bit and I am going to assign it to the output bit. So output bit means what? It is port number 2 and line number 7. So this is a very simple program to read one switch, store the value, and send it to the next port line. Let us simulate this program in a kill compiler. Let us go to the kill compiler. So once again you right click, add an existing file to source group 1, assignment number 4, add and close. Double click. So here is the program. So first of all we are going to read the switch which belongs to port number 1 line number 0, and then we want to send this bit to the port number 2 line number 7. In between, what we want to do is we want to store that bit within the single bit addressable area. As you can see that these are all single bit variables, and this has to be declared before void main void. So let us try and simulate this program. So I'll go to debug. So first of all you need to build this program. We'll build this program and I'll getting 0 error and 0 warning. Debug, start stop debug session. Okay. Now here we'll observe the deassembled code, and we require port number 1 as well as a port number 2. So I'm already having port number 1. So I'll go to peripheral and I will choose port number 2. And I will take them side by side. Now we'll run this program step by step. So I'll click on this. As you know that by default all the ports are output port. So that is why we are getting value as in 1, and so that it is copied to the port number 2. What we are observing is port number 1 line number 0. So here is this bit. So I'll click on this to make it 0, as this is input port. So same should be reflected on port number 2 and line number 7. So let us click on this. Now I have made this bit 0 and try to run it again in a stepwise manner. So here you can see that. So value is 0, and here add the 2.7 as well, the value is 0. So it will remain a 0 until and unless I will make it 1. So let us make it 1. So you have to click over here to make it 1, and once again if I simulate this, now the value become 1. So you can imagine that here at P1.0 I have connected a switch, at 2.7 I have connected LED. So status of your switch will be reflected on LED. So we'll stop the session over here. I'll come out of this debug mode.